Excellent, I hope. So, welcome to step 3, as Rob just explained. And as Rob just said, if you have any questions, just raise your hand and I'll answer them immediately, since I do sometimes speak a bit fast. If you want me to speak slower, you can indicate that as well. So far, you've been working mostly on, steps 1 and 2, which means you've been working on matrices, and more matrices for the target behavior and for the environmental agents. And then we'll be working towards the intervention, which you will create in step 4. Unity is an intervention in Dutch nightlife settings. It's a so-called peer education intervention, where people who use substances explain to other people how to use substances with as little harm as possible. And I work a lot with them, so I have a lot of examples from them. So that's what we want to move towards the intervention, which you'll develop in step 4. So in between, we'll start looking at why the intervention would actually work, which is basically what step 3 is about, the stuff under the hood in the intervention. Step 4 will be about basically spray painting the car, and step 3 is about the stuff under the hood. So you have all these interventions. These are all nightlife interventions, because that's kind of my substantive area, if I have one. And with those interventions, we want to increase people's health and/or quality of life. And unfortunately, as by now, hopefully you're aware, we can't actually intervene on health or quality of life. Because unfortunately, we have to work through people who are kind of in the middle and whose behavior determines their health and their quality of life, generally, together with the environment, of course. Behavior is generally defined as motor activity, so stuff your muscles do, such as when you speak or when you move. And that's controlled by the central nervous system, which, as psychologists are generally well aware, is controlled by the human brain, so basically people's psyche, which is psychology, gives us a useful perspective to help make the world a better place. So the question is, if you want to change behavior, how do you make sure that the right signals are sent to the motor cortex at the right time? The challenge here is that this is generally how the brain is depicted, how neurons, what we know about how the brain works. You have brain cells and they activate or inhibit each other. And we have a lot of those. We have like 90 billion brain cells. And there are about 200 billion stars in the galaxy, to give you some perspective, and 8 billion people on the planet, which is like a lot. I know maybe 1/3 of those, just to give you some sense of perspective. And they are connected to, and this is, as Rob explained, I did cognitive ergonomics, so I didn't do the biological psychology track. Since you're here, I think you did neither. So my image of a brain cell is what I learned in the textbooks way back in, the second course in the first year here, which is like the neurons as they're painted or drawn at the background. So you have a neuron, you have 2 or 3 dendrites going to other neurons. Apparently there are like 7,000 on average. I can imagine why they don't draw those, but for me it was kind of a shock. So that means basically there's a lot of information that you have to record, have to study, if you want to take this bottom-up approach to changing human behavior. So even though we know that if you want to change behavior, this is what you have to change, actually working from neurons upwards is not a feasible strategy. So now we are going to work towards what is a feasible strategy. But first, as Rob kind of promised already, I'll briefly summarize the stuff in step 2, because sometimes in the groups people start deviating a little bit in how they define things, and it's useful to have everybody on the same page with the vocabulary that I will then use for step 3. So we want to improve people's quality of life. And we assume that quality of life is to a large degree determined by health and by people's behavior. And we know that both of these are determined by what people do, people's behavior and personal determinants. So actually not what they do, just the personal determinants, and their environmental conditions. So on the one hand, you have people's environment. So the person is in the environment where you have the interpersonal environment, so we are each other's interpersonal environment now. You have an organizational environment, which is kind of like an interpersonal environment, but larger generally, not always. Plus, and that's the important bit, you have formal structures, like hierarchies, which means you can do things which you can't do if you're not in an organization. So with us, there's there's a little bit of hierarchy, but there's not really a hierarchy. If Rob and me weren't here, there wouldn't really be any hierarchy. In an organization, you have managers, and you can basically change what's served in the cafeteria, and then that's just what it is. So you have tools available for change that you don't have at an interpersonal or personal level. Then you have communities where you often have informal leaders, which can also give you tools for change that you don't always have available at other levels. Then you have societies like the Netherlands, where you have governments. And then you have the supranational level, where you have, for example, the WHO, which can have guidelines about distance keeping when there is a pandemic, to give a random example. So you have all these environmental conditions, and then, of course, you have the stuff within a person, the personal determinants. Together, by definition, they form the entirety of the world, because everything in the world is either within a person or outside of the person. And everything outside of the person is divided into these levels. And generally, not everything, but most things in our world are under control of other humans. Okay. Behavior is generally, when we talk about behavior, we use an umbrella term. We use a generic term like having safe sex, or exercising, or having a healthy diet. Those are so generic that if you want to actually have any chance of changing them, you have to split it up into sub-behaviors. And we call those performance objectives in behavior change, because they are objectives of what people have to perform when we're done with the intervention. So the performance objectives are the sub-behaviors that have different determinants and or environmental conditions. That's kind of the criterion for when you start or stop splitting up the sub-behaviors. Because of course, in theory, you can split up any behavior. I mean, as I said earlier, behavior is ultimately defined as motor activity, so muscle stuff. But if you're talking about safe sex and you have condom use, for example, putting on the condom is one behavior, because the same environmental conditions and the same personal determinants determine whether people put on the condom or not. The fact that you have different small activities with your fingers, for example, like opening the package and stuff, you don't have to separate those into sub-behaviors, even though they are sub-behaviors. Like this is a different behavior from taking out the condom. Those are different behaviors. But you don't have to split those up in intervention mapping, because they have the same determinants and the same environmental conditions. And splitting up the behaviors into performance objectives is only a tool to make sure you don't miss anything when you develop the intervention. So as long as the determinants and the environmental conditions are the same, you can lump everything together, but if they might be different, you split it. For example, the determinants of buying condoms in the shop are very different from the determinants of negotiating condom use in the heat of the moment or before the heat of the moment with your partner. People just have different reasons why they do or don't do those things. So those you have to split up. So we have behavior, we split it up into performance objectives. The performance objectives are determined by personal determinants and environmental conditions. And those environmental conditions are actually under the control of environmental actors, generally. I mean, we have storms and tsunamis and thunderstorms and other things, but most things in the world that people struggle with, most obstacles, most things in their environment that can facilitate a behavior, are under the control of other people. And of course, those people exert that control with behavior. They take a certain decision, they do something. And then again, this behavior is split into performance objectives. And the performance objectives are predicted by environmental conditions and personal determinants. And those environmental conditions are again under the control of other environmental agents. So once you know how to change personal determinants, you can change the world. So that means it all boils down to the brain, which is, of course, very convenient since this is a psychology study. And we know in the brain we have to do something with this motor cortex thing. The motor cortex is, in that sense, simple, because we know it's roughly there, and it's pink, as you can see. But most other determinants don't have a specific place in your brain. It's not like people's attitude regarding buying condoms is located there and is round. So we can't actually, again, use the brain to try to map what we have to change and try to change it because of these neurons. So as you, even though you didn't choose a biological master track, probably remember these neurons can activate and inhibit each other, and then you have this pattern called spreading activation. So that's basically what we work with in the end, but this is still useful because it gives us a metaphor for how to think about the human psyche at higher levels as well. And to illustrate this, there's a brief task which you may or may not have encountered and or remember from your bachelor. So the idea is, the only thing you have to do, so I hope you had coffee, is remember the list of words that will now be shown, one by one. That's all you have to do. And when the list is done, I'll show you a second list, and some of the words in the second list will have been in the first list, and some won't. And obviously, you're not allowed to write them down. You're allowed to record it, because you don't have time to go back and watch it anyway, but you're not allowed to write them down. Ready? Anybody still needs to get coffee? No? Okay. Okay, there we go. Cloud? No? Go on, you make a bit of sound, eh? You don't have to be super. It's Monday morning, but... So, cloud? Hospital? Office? Table? Dentist? Lawyer? Sick? Carpenter? Doctor? Oh, that actually went much. This is the first time this goes reasonably well. Very unfortunate. Because this almost always works. So, who here knows this test trick? Nobody? So you actually didn't know it? Hey, you actually performed really well then. So this is the Dees-Rudiker-McDermott paradigm, which I remember from my bachelor, but clearly it's been chucked out since, or you did your bachelor elsewhere. The idea is that all these words, actually I can show it, all these words are strongly related to each other, the words in the first list, and they're all strongly related to the word doctor, which, oh, did I actually not? Oh yeah, we did. They're all strongly related to the word doctor, which was not actually mentioned. But this spreading activation pattern also works, is the theory, at the conceptual level. So if you encounter these words, the words activate the doctor concept, and when you try to assess whether something was in the earlier list, you can't actually rewind the recording of what happened. So the way you do it is using metacognitive skills, which in this case, one of them is assessing the degree of activation that the doctor concept has in your mind. And because it achieved so much activation because of all these related concepts, you think it was actually activated. So all this to illustrate that your mind, it's useful to think about concepts as activating and inhibiting each other. That means that if you have any behavior, you can conceive the behavior as being represented by people as a combination of attributes. And some are desirable, some are undesirable, but for any behavior, people can expect that they feel more or less ashamed if they do it, or they find it more or less interesting, or more or less pleasant, or they think they have the skill to do it more or less, or they see more or fewer obstacles. And then what you can do, if you are a psychologist and you study the human psyche, you can say whether people intend to engage in a behavior basically depends on all these attributes together. And then you can even split it up further. You can say people's attitude, we define attitude as this cluster of expectations that people can have. And we define norms as this cluster of expectations. And we define perceived behavioral control as this cluster of expectations. And usually, the clustering, basically the definition of psychological constructs, happens either because the sub-constructs are similar or functionally similar. So either they kind of look alike, or they kind of work alike. And then, as psychologists, basically say, okay, we draw a little line, we say, okay, this is a construct, we slap a label on it, and that's kind of what we do. What you see then is that in different theories, you can have the same bits of the human psyche that are included in constructs in those different theories. So experiential attitude is a construct from the reasoned action approach, and intrinsic regulation is a construct from self-determination theory. And they both quite explicitly contain the degree to which people find something pleasant. So that means that if you do behavior change, your goal is to find all the little balls, all the nodes in the network. And that means that you generally don't stick to a theory. Because every theory is developed with a specific goal to explain specific behavior in a specific context, for example. And that means they were all designed to only capture a part of the human psyche, within the context for which they were designed. Whenever you want to change human behavior, you don't want to understand a little bit of people's behavior or a little bit of people's psyche. You want to understand everything, but in a very specific context, for a very specific population. So then your goal is not to find general mechanisms that work for all humans. And to do that, you need the constraint that you only study habit behavior or reason behavior or other types of behavior. You actually want to study a single behavior in a specific context for a population. So you want to study the entire psyche. So you work kind of the opposite way. These theories are generally then represented like this, like boxes and arrows. Those representations are kind of similar. You can't even empirically, like with quantitative or qualitative research, distinguish these two. Because what you do is basically look at correlations or do experiments and change things. But of course, if you change attitude and then intention changes, you can't know whether that is because attitude is something distinct from intention and intention is caused by attitude, or whether intention just contains attitude, which are different statements about the world, but you can't find out which is true if you do empirical research. So these are kind of comparable, but it's useful to keep in mind the top right one, because the bottom left one kind of almost makes you think that you have to use one of those models. And the one at the top right makes it a bit clearer that it's about finding all the balls, so to speak. Okay, so we have a human, as you can see, a very lifelike human with a brain. In this brain, we have these constructs, these determinants, and those are generic. They're defined at a generic level because the idea is that they're studied for humans and for behaviors. They're not studied for negotiating physical intimacy between two adolescents from a suburban region in Utrecht, for example. And then you have different levels of these constructs. At the lowest level, you have subdeterminants, and subdeterminants are super specific. They are always valid for a specific population or a specific behavior. And then at the top level, you have the theories, and at the bottom level, you have the little balls, which of course are captured in the theories. And there are loads of levels in between, of course. There are no, because we can't observe the human psyche directly anyway, so none of the levels is correct or incorrect. We just use levels that work for a given goal. So you can distinguish infinite levels in between. So at the top level, you can have intention. You can have people's intention or motivation to drink coffee at lunch. And then if you get a bit more specific, you can say, okay, but that intention is predicted by or consists partly of attitude, which is basically about people's expectations, what happens if they drink coffee at lunch. And then you can have their experiential attitude, which is only that subset of expectations that has to do with people's experiences or expectations of experiences. And then you have the specific belief that if you drink coffee during lunch, you feel more energetic. And then you have the specific belief that if you drink coffee during lunch in Maastricht, you feel more energetic. These bottom levels are more the levels of the change objectives. And those are called subdeterminants. So you have the human psyche, consisting of constructs. At least that's how we approach them scientifically. Those constructs are quite generic, but they can become more specific. And if you are at a sufficiently specific level, we call them subconstructs. And that's the level where you actually can communicate to people. Because if you ever develop an intervention, you can't tell people, have a high intention. I mean, you could, but it generally won't work. Because the idea is that these generic, broad constructs are actually determined by specific representations people have about the world around them, about what other people want them to do, about whether they have certain skills, about whether they will feel happy when they do something. So if you communicate in an intervention, you always communicate at this lowest level, at a level where you can actually explain what will happen if people do something, what other people will think. We still need the higher levels though, and I'll explain why in a second. So we have nodes in the network, which are subdeterminants. And then in step 2, you may or may not have worked with this specific spreadsheet, but there are tools like this spreadsheet to create a long list of subdeterminants, all the bits of people's psyche that might be relevant for a given behavior. And then out of the long list, you make a selection of the things that you want to target. And those then become the change objectives for your intervention. And the selection is generally based on how relevant you think it is, so how predictive it is of the behavior, how big of a cause it is of the behavior, and how changeable you think it is. Because of course, as everything in the world, the things that are very important are harder to change, and the things that are easy to change, like knowledge, generally don't really matter so much for the behavior. Okay, so not only is the behavior split in sub-behaviors, performance objectives, the determinants are also split in sub-determinants, and the sub-determinants you select are then called the change objectives. For the change objectives, you have these specific formulation rules, which you probably encountered. So they have to be formulated like SMART goals, basically. That's a bit confusing, so keep that in mind. The change objectives, if you formulated them properly, they're formulated as behaviors. Because they're formulated as the behavior that, if somebody from your target population exhibits the behavior, give you evidence that that bit of their psyche is desirable, has the right value or whatever, has been changed. For example, people list the advantages of getting your ecstasy tested. If people list those advantages and they're accurate, then you know that they have the relevant knowledge. You can also say people know the advantages, but the reason that in intervention mapping you're not allowed to formulate change objectives like that is because, of course, you can never evaluate that. It's very easy to evaluate whether they can list those. So the change objectives, so for subdeterminants, you don't really have formulation rules. Subdeterminants are just a way to describe a bit of people's psyche that you think may or may not be relevant for a performance objective or a sub-behavior. And then you have this long list, you make a selection, and then for the selection, you reformulate the subdeterminants as change objectives. Which means you formulate them smartly, which means you formulate them, slightly confusingly, as behaviors. But they're not behaviors, they're just ways to know that people's psyche, bits of people's psyche are such that they push them towards the desired behavior or whatever. Okay, you did study the cyber plots, I guess, already, that Rick, I guess, presented about. So the idea is you have the univariate distribution. So you basically see to which degree your population believes something. So you see for the second one that people remember less after a high dose of MDMA, which is true. Generally, most people believe this. So that's obviously this was mostly a sample of people who go to dance parties and use ecstasy from time to time, so they have probably experienced this. And you see the people do believe that it's actually easier if you use a high dose of MDMA. That's actually also not true, but that is people's experience sometimes. Maybe partly because that's not here. You also remember less if you use a high dose, so it's also relatively easy for false beliefs to be retained. So here you see how people score in your population, so where there is actually any room for improvement. And here you see on the rightmost side how strongly each of these are related to intention, attitude, behavior, whatever the target is. So you use those two sources of information to kind of estimate which ones you want to target in an intervention. If stuff doesn't correlate with intention, it's relatively unlikely that changing it will contribute to behavior change. On the other hand, for example this one, people already know that if you use a higher dose, it's worse for your health. So you can't really change anything there. I mean, you can try to convince the few people who are a bit more to the center to go a bit more to the bottom, but that's of course a relatively small effect size. You won't achieve much behavior change there, even though it's positively correlated with not dosing highly. Okay, so then you kind of started working on what we call the causal structural chain. And the causal structural chain summarizes the causal and structural assumptions you have about why your intervention will work. So at the end, your ultimate goal is to change people's target behavior. And target behavior is split up in sub-behaviors. The sub-behavior is predicted by one or more determinants, which consist of one or more sub-determinants. And then there are 3 links left. And those are the links of step 3. So, to go back a bit, what we eventually want to change is something in those 7,000 connections, on average, between those 8 billion brain cells. And we can do that because through evolution, organisms evolve the capacity to learn. And the first learning process that evolved was habituation, which basically means ignoring stuff that doesn't matter. So if you can't eat something, or it can't kill you, and you can't procreate with it, you can ignore it. And you can kind of see already how this can have an evolutionary benefit as opposed to the first organisms who couldn't yet habituate and therefore try to eat everything or run away from everything or hump everything at the same time. So this was quite beneficial in terms of saving energy for other things that you can eat or that can kill you or that you can procreate with. The second evolutionary learning process that evolved was sensitization, which is kind of the opposite. It's basically if you experienced, for example, if you burned yourself, right afterwards, everything will feel hotter where you burned yourself. So habituation kind of decreases signals like that reach your brain, basically, and sensitization increases them. Then the third one that evolved was classical conditioning. And you probably know that from Pavlov, who noticed that when he entered his laboratory, the dog started drooling. And it turned out that was not because the dog was very attractive to him, but because he always fed the dog right after he entered his laboratory. So then he was like, oh, that's interesting. So the dog recognizes my footsteps and then prepares for eating. So something, a stimulus that's actually completely unrelated to food, namely the sound of footsteps, has become associated to another stimulus, food, in the dog's mind. And then he started playing around with it, and that basically became the classical conditioning paradigm as we use it now. So this is quite powerful because it allows organisms to associate things in the world to each other. So that, for example, if you hear a saber-toothed tiger, you may have heard one when you came to the university, then you know that you should probably cycle faster. Operant conditioning is the same but applied specifically to behavior. So if a behavior has positive effects for you, it's likely to increase. If a behavior has negative effects, it's likely to decrease. So it's again associating a stimulus, but then associating a stimulus to a behavior instead of to stimuli in the environment. Then affective learning is even stronger because it evolves later, so of course it's got to be better than the preceding ones. Affective learning is the ability to generalize over stimuli. So then you can also understand that you might get food if somebody else has entered the laboratory. So affective learning basically, so feelings, are basically that when you go to a city where you've never been before, and you see a shortcut through an alleyway, but it looks a bit dark and dangerous, then you're like, oh, I might not want to go there, because it doesn't give you maybe not a scary feeling directly, but it doesn't feel right. That's because basically it's similar to other stimuli that you learned are negative. So that's effective learning. Similarly, when you feel positive about something, that means you have expectations that it will have positive effects, even though the thing might not have occurred to you before. Then procedural memory it's a bit more boring. It's combining motor programs into a larger motor program, like bicycling or tying your shoelaces. Apparently tying your shoelaces is super hard if you do it deliberately. I've never actually tried it, but apparently it's very hard because you just automated the whole thing into one motor program, which you can do because you have procedural memory. Cognitive maps are the fact that organisms create maps of the world around them, which they can then use to navigate, allowing them to take routes that they've never taken before, because they can reason about how they get somewhere. This is important because it doesn't require symbolic representation of the world per se. It's really just a map, and it only works for spatial information. Vicarious learning is used a lot in behavior change interventions. So that's why I made a brief movie to explain it, which is a lot of work in PowerPoint, or at least it used to be until PowerPoint 2016. So that means it is very short. So you really have to pay attention to enjoy this masterpiece. Ready? He's dead. Which is sad, of course, as I notice you realize from your response. But it's good news because it allows us to explain that Fred Flintstone now knows that he shouldn't go into the bush. This is the first learning process that evolved where an organism didn't need to experience something for themselves. All the other learning processes only work for the organism themselves. Here, they can learn through observation, vicariously, so to speak. So that's super powerful, and we use that all the time here. Actually, we use it right now. And you use it when you read a book, you use it when you learn to drive a car. Most learning here, a lot of learning about stuff pertaining to you, not declarative knowledge about string theory, but stuff pertaining to you, is learned through vicarious learning. If you would have to learn everything you know now about how the world works by doing everything yourself, you would know much less. So this is super powerful. And we use it a lot. But of course, people don't just copy everything they see. So there are very strict parameters for all these things to work. With vicarious learning, for example, imagine that you have like a saber-toothed tiger, and he's sitting on a mountain, on a cliff edge, and he's really hungry, and then he sees a bird fly down the cliff edge to eat, well, let's say it's a predatory bird, so the bird eats a cow, and the saber-toothed tiger is also very hungry. If the saber-toothed tiger would now copy the bird's behavior, and also jump off the cliff, that would be his last jump. So those saber-toothed tigers have been selected out by evolution. So now the saber-toothed tigers and humans and other organisms that can vicariously learn only copy behavior of other pairs that they identify with. Because of that, humans generally don't copy behavior and interventions by celebrities, for example, because those are not pairs they identify with. Similarly, if the target behavior that's modeled by the model, by the pair, for example, isn't rewarded, isn't positively reinforced, it's also not copied. And if people don't have the skills, it's also not copied. So these evolved learning processes are super useful, and that's actually all we can use, because this is pretty much the ability of organisms to learn. So any learning that takes place, any change in somebody's psyche that is kind of retained, that works through these, but none of them evolved for use in teaching or use in behavior change interventions. So that means if you want to use any of them, it's very important to stick to those parameters of use that determine when they work. Abstract concept learning, so the ability to relate abstract concepts to things, came later. As far as we know, only some primates and us can do this. And then the last one that evolved that we know of is reflective learning, which requires an episodic memory. And it basically consists of thinking back about last Saturday and thinking like, oh, was that so smart, and should I maybe do it differently, and how shall I do it differently, and stuff like that. So these evolved over time, which means that the first organisms, like single-celled organisms, they can already habituate. Cognitive maps exist in some insects still, so good for them. And as far as we know, we're the only ones who evolved to the point where we have reflective memory and this sense of time going on and having a personal history and stuff like that. As far as we know, this is how organisms can learn, as I said. So that means that if you want to do anything with behavior change, you use these. But they're super rudimentary. So when we use them, we actually don't use them. We use behavior change methods, or techniques, or principles, which themselves leverage underlying evolutionary learning processes. So, for example, planning coping responses, that consists of talking with people about what might go wrong if they want to do a certain target behavior and how they can cope with it, what they can then do to still perform the target behavior. So, for example, you want to help people exercise more, and they say, okay, I put my shoes next to the door every morning, and then when I get home, I have a cue, and then I remember to exercise. And then you sit down with them, if you have the luxury of having a person for the intervention, and you say, okay, so imagine that you do that, what could go wrong? And then they're like, well, it could rain. And then you say, okay, so if it rains, what do you do then? And then you think of a plan for that situation. So this is a behavior change method, and it uses these two underlying evolved learning processes. Of course, using the behavior change method is much easier, because those just come with a kind of manual and with these so-called parameters of use. Here at the bottom, they have to practice the response that determine when they work and when they don't work. And these we, of course, know from experimental psychology. So researchers put people on the boards. Yes, a question? Yes, the question is whether planning coping responses is similar to implementation intentions, and yes, that is completely correct. There's, around the implementation intention literature, you have another, well, I don't know whether it's another theory, but somebody proposed to separate coping responses from action planning. So action planning is the more the traditional implementation intention, dealing with when you're going to do something, like when I see a mailbox, I post a letter. And then the coping planning the coping planning is about if you want to do it, but something goes wrong, then what do you do? So it's kind of like a second level. But yeah, it's very similar, very good. Okay, so those parameters of use and the manuals come out of research, experimental research, where researchers put participants into 2 or 4 or 8, whatever, groups, and then manipulate those parameters or manipulate different ways of applying the method. And that's how we kind of learned over time which work when. Another example is threatening communication, which I hope you've been, which has been explained a few times already, that threatening communication generally doesn't work because people have a lot of protective mechanisms, unless the alternative behavior is relatively easy and they are confident they can do it. But if people are not confident they can do it, then threatening them basically results in them having a lot of reason to negate the threat mentally, because otherwise it's very threatening to them, of course, that they do something which is bad for them. And to stay sane, we have a lot of mechanisms to not stay in that state. So then you think like, when you confront smokers with the fact that smoking is bad for them, then they might say, if they can't quit, they might say, yeah, but my grandfather is 93 and he smokes a pack a day. Or, yes, but I eat a lot of broccoli and I work out a lot, or etc. So all of these behavior change methods that you use, because they use learning processes that never evolved for us to be used for behavior change, you have a very small margin to get it right. But fortunately, we know more and more about research how to stay within that small bandwidth. So those methods are all in the intervention mapping book and in this open access article. So then the next question is, which methods do we have to choose if we want to change behavior? If you talk to people about what they do, then you get these kinds of responses. This is again about this higher dose of ecstasy use, because it's a study which I just did when I created this slide deck, I guess. Then these are the kind of considerations people have. So they think about whether they like the effects of a high dose versus recommended dose, what their friends think they should do, whether they can even obtain pills with a low dose, whether a high dose facilitates connecting to others, whether a high dose gives them more energy than a normal dose, whether their friends use a high dose themselves, which of course is something else from what their friends think they should do, whether they are able to determine the dose correctly, whether they will still remember everything if they use a high dose, whether a high dose is more unhealthy, whether it makes you hallucinate more, whether they like to hallucinate more, because some people do. Of course, MDMA is not the best drug, so in case you like hallucination, don't use MDMA. But still, if people have only access to MDMA, they might still resort to using higher dose MDMA to get some more hallucinogenic effects. So that's what you get when you talk to people. So now the question is, how do you connect this to the methods of behavior change? As you notice, the things on the left, those considerations, they are all on the level of subdeterminants. They are all sufficiently specific to directly intervene on if you want. The only thing you have to do is find out which ones are relevant and how to effectively intervene on them. And that's where theory comes to the rescue, because as we discussed earlier, theory basically clusters all those subdeterminants into constructs, determinants, that are either similar or contain similar subdeterminants or contain functionally similar subdeterminants. So they either contain determinants, subdeterminants like considerations, thoughts, expectations that look alike on the surface, or that work alike in people's psyche. And then you just say, okay, we call this cluster attitude, we call this cluster self-efficacy, and then we put them in boxes and we add some arrows, and voila, we have a theory. And then these methods for behavior change target specific determinants. Because those determinants, of course, describe parts of people's psyche that work a bit the same, and therefore relate to different types of memory, you could almost say. So when you want to change norms, norms work differently, social information works differently for people than pure expectations about whether you will feel pleasant if you use a high dose of ecstasy. So if you want to change these, you have to use different underlying evolutionary learning processes, which means you have to use different behavior change methods. So the behavior change methods are organized by determinant, and that's why you still need to know both the determinants and the subdeterminants. You need to know the subdeterminants because that will be the content of your intervention. That's what you actually communicate to people, that's what you want to change. And you need to know the determinants because those are more generic, and those allow you to find out what you can use to change the subdeterminants. And it's important to keep in mind there are a lot of theories about the human psyche, and there are therefore a lot of constructs and a lot of determinants that you could target. So this can be quite overwhelming, and if you do determinant studies, you have to think carefully about which of these you include, which theories you use. But it's also important to not get distracted by the fact that there are so many determinants, because it's not actually about the determinants, it's actually about the subdeterminants. You want to go back to English? The slides are online, by the way, behind the QR code, so you can also get a high resolution version. So there are a lot of determinants, but eventually it is about the subdeterminants because that's what you target. You just need to know which determinants they belong to know what to target them with. Okay, time for a little break? Excellent. Shall we do 25 past? Excellent.